This is my second video covering graphing radical functions. So if you haven't already looked at the first one, make sure you go take a look at that so you can get a sense of what's going on here. In the first video, we went through graphing radical functions just by making tables of values, plotting points, and going through there. It works, but it's a little bit time consuming, especially because you have to kind of figure out which numbers you're going to need to plug in to make the whole thing work. So in this video, I'm going to go over how to do a little bit faster. So let's say we wanted to graph something like y equals the square root of x minus 1 minus 2. So graphing radical functions is a lot like graphing something in vertex form, if you know what to do. So remember, your vertex form was a x minus p squared plus q. And so remember, that gave you your vertex at pq. So this doesn't have a vertex necessarily because it doesn't have sort of that curve in it, or that bend, but it does have an endpoint. Right, where the graph stops. And so if we go back and we check out some of the previous ones from the last video, you might see that the endpoint tended to move around a little bit, and you might notice that there's a connection between the endpoint and these numbers inside of your root and beside your root, which are basically like p and q. They're not quite the same, but they're basically the same. So this graph is going to have an endpoint at 1, negative 2, which works just like the vertex. And our a value is 1. So just like with quadratics and just like with parabolas, we can use the same pattern that we had in the last lesson for y equals the square root of x. And so I'm just going to tell you what that pattern was, but if you want, you can go back and double check and see what you get. So the square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. That was our pattern. And if you look at that, that pattern itself should be pretty familiar, because that is the same pattern that we used for parabolas, just with the x and the y flipped. And so let's go ahead and try to graph our parabola here. So we're going to make ourselves a graph that goes up to 5, down to negative 5. Let's go over to negative 1 and up to positive 10. So go ahead and sketch yourself some axes that will fit based off of that description, and then we'll try actually graphing our radical. All right, so our starting point was at 1, negative 2. And then our basic pattern is go over 1 and go up 1, go over 4 and go up 2, and then go over 9 and go up 3, which again, it's just the same pattern as parabolas, just flipped. So if you literally take your page and you rotate it now, you'll notice that you basically have half of a parabola here. And if you mirrored all these points, which we're not normally going to, but I'm just going to show it, really like that right there, that is a parabola. So it's the same pattern working in the same way, just flipped slightly on its side. And so there we are. That is our radical function, but graphed a little bit more easily. If we do maybe domain and range here, because that is something that might come up from time to time. Remember, for domain, you want to look at your smallest and your largest x values. So our smallest x value is 1. We don't actually have a biggest x value, so we'd say that either 1 is less than or equal to x, or x is greater than or equal to 1. And then for our range, same idea. Our smallest y value is negative 2. So we have negative 2 is less than or equal to y, or y has to be greater than or equal to negative 2. All right, let's try another one. So we're going to graph y equals 2 root x plus 5 plus 3. So our graph is going to start at which point? So again, think vertex form. Our p-value, it's not actually p, it's a different letter, which I'll get to later. But our x-coordinate is going to be at -5, and our y-coordinate is going to be at +3. So that works basically the same way. So we're going to sketch ourselves a graph. This one's going to be really big because we're going to put a couple of equations on it. So we're going to go all the way up to 10, down to -10, and over to 10 on each side. So take a few minutes, get yourself that graph done, and then we'll talk about how to graph this thing. All right, so our starting point we said was at -5, 3. So our first point goes there. That's great. But unlike the last example, we do have an a value other than 1 here. So we've got to think. Remember, our basic pattern is over 1, up 1, over 4, up 2, and over 9, and up 3. So just like when we were dealing with quadratics, that a value is actually going to do the exact same thing. So if you remember back then, it multiplied all of your vertical distances by a. And we're going to do the exact same thing here. And those vertical distances, 1, 2, and 3, are all going to get multiplied by our a value, which is 2. So we multiply the vertical distances by a. And so our new pattern is going to be over 1, up 2, over 4, up 4, and over 9, and up 6. So we're going to go back to our point and just do all those points. So over 1, up 2 puts me there. Over 4, up 4 puts me here. And over 9 and up 6 puts me up there. And so those are our points. We'll draw a curve through them as best we can. And so we're going to end up with something that looks like this. And there we are. So there is our radical function. So I'm going to give you another one to try on here. So you're going to use the same graph, which is why I gave you all this space down here at the bottom. Try graphing this one on your own. Follow the same process. See how it goes. So you're going to graph y equals -3 root x plus 6 minus 1. So think carefully about what those numbers mean, what they do, and then come back and see how you did. All right, so our starting point on this graph is at -6, -1, right there. Our a value is -3, so if you think back to when we were doing parabolas, remember that negative flipped your graph upside down, and that's still going to hold true here. So instead of going over 1 and up 1, we're going to go over 1 and down 3. Then we're going to go over 4, and instead of going down 2, we're going to go down 6. And then we're going to go over 9, and we're going to go down 9. It's going to put me right down there. And so we've got our points. We're going to draw our curve as best we can. And there we go. So hopefully you got that right. You just got to keep an eye on that negative, and remember that it's affecting your vertical distances, not your horizontal distances. So I know it's a temptation to multiply the 1, the 4, and the 9, because that's what we did when we were dealing with parabolas, but those are now horizontal. It's the a's, or the verticals, that get affected by a. If you haven't already, think about doing your domain and range here and see if you can come up with something correct. Then come back and see how you did on that. So our domain, we're going to focus on x, and our smallest value of x is -6. And the graph keeps going up from there, so we want to be above -6. We don't have a biggest value. For our range, we've got y, and our biggest value of y is -1, and the graph goes down from there, so we want to be less than -1. And so there's our domain and our range. All right, so let's see if we can go the other way now, right? This is something we did with quadratics as well, was going from a graph back to an equation. So how do we determine the equation of a graph? the process is going to be pretty similar. So if you understood how to do this back in chapter 4, you should be pretty okay doing it here. Or sorry, chapter 3, you should be okay here. If you don't remember how we did it back then, I'll do my best to explain it, but it might not be a bad idea to go back and check out some of the 3.1 videos. It was probably 3.1.3 to see how we did it with parabolas, and then come back here if you're feeling better with it. So let me draw you a graph, and then we'll talk about it. All right, so we've got our radical function. We want to write out an equation for it. So the first thing we want to do is find the endpoint of our graph. And we're going to plug it into our equation. But what equation are we plugging it into? Well, we'll get to that in a sec. So our endpoint is over here at 0, 3. All right, so that's our starting x and y coordinate. And so our generic radical function, the thing that we're going to be plugging our values into and using to figure out the actual specific equation here, looks something like this. It should be pretty familiar because it is pretty similar to vertex form. It's going to use some slightly different letters in some places, but the process is pretty much the same. So we're going to start with y equals a. That should be something you definitely recognize. Then we've got our root. And so instead of x minus p, it's going to be x minus h. And then instead of q at the end, it's going to be plus k. But otherwise, that should look pretty much like vertex form to you. And it works very much the same way. So if our endpoint is at 0, 3, we're going to plug that in. And so we're going to have y equals a times x. And then so our x value here is just 0. So x minus 0. And then our y value is 3. And so I can do x minus 0 and just get x. This is y equals a root x plus 3. Great. And so now all we need is to figure out that a value. And we're going to do that also the same way we did it back in chapter 3. So what we do is we pick a different point, not your endpoint, and we're just going to plug that point in for x and y. And then once we've plugged it in for x and y, we're just going to solve for a. You can also try to do this using the pattern, but that's not always super reliable, especially on a graph like the one we had here where some of our points aren't super clear. So doing it the way that we're about to do it is definitely the safer option. So if we look at our graph, we need a different point, a different clear point that we can plug in. So we're not going to use this point or this point because those are both in between. We don't know the exact decimal value necessarily. We can guess they both look like they're at about 0.5, but we don't know for sure. So instead, we're going to use this point here, which does seem to be a clean point at 4, 6. So that's the point that I'm going to be plugging in. So we go to what we had, which was y equals a root x plus 3. And I'm just going to plug 6 and 4 in for y and for x. So we've got 6 equals a root 4 plus 3. Well, the square root of 4 is 2, so this gets me 6 equals 2a plus 3. And so now we just want to solve this. So we're going to subtract 3 on both sides, which gets me 3 equals 2a, and we're going to divide by 2, which tells me that a equals 3 over 2. And then we're just going to put this all together. So our final answer is y equals 3 over 2 root x plus 3. All right, so I'm going to give you one more graph to work with to try this out on your own, and then that will wrap us up with radical functions. It's not something we're going to spend as much time with as we did parabolas, because it's really just contained to this particular unit. So once you've got this graph that I'm going to make down, see if you can figure out what the equation is. All right, so there's the graph. So go ahead, give this a shot, and then come back once you're done. All right, so our starting point is over here at -5, 4. So to kick things off, we've got y equals a root, and then so since it's -5, this is going to be x plus 5, and then plus 4. So now we need another point to plug in, and we've got options. Try to go for whichever one seems like it gives you the easiest numbers for you. I'm going to go with this point right here at -1, 0, because I like zeros. So my y value is 0, and I've got a, my x value is -1, plus 5, and then plus 4. So -1 plus 5 gets me positive 4. The square root of 4 is 2. And that gets me here. So we now need to solve this. We're going to move that negative or that positive 4 to the other side by subtracting. So we've got -4 equals 2a. We're going to divide both sides by 2. And we get that our a value is -2. And so to put this all together, we've got y equals -2 root x plus 5 plus 4. And there we go. That does it for radical functions, and that actually does it for chapter 5. So go back through this, make sure you understand how to add and subtract radicals, how to solve equations, how to do some graphing, how to find restrictions, and all that stuff. And then in chapter 6, we're going to start something new when we learn about something called rational expressions and equations. So if you're ready to move on, go take a look at those.